Wave scattering is a natural phenomena which can be seen everywhere around us. Broadly classifying, there are three types of scattering. Relay scattering, elastic scattering of light or other electromagnetic radiation by particles much smaller than the wavelength of the radiation. Mie scattering, broadly, Mie scattering suggests situations where the size of the scattering particles is comparable to the wavelength of the light, rather than much smaller or much larger. Geometric scattering, whenever the obstacle size is much larger than the wavelength of the radiation, here the laws of geometric optics are mostly sufficient to describe the interaction of the light with the particles. At this point of interaction is not usually described as scattering.
Here in this video, we are going to explore various possibilities whenever a wave encounters an obstacle by playing with the obstacle size compared to the wavelength of the wave. For this, we use the finite difference time domain method. The parameters used for simulating the setup are shown below. Size of the lattice is chosen 5 lambda by 5 lambda, where lambda is the wavelength of the light. Metal obstacle is used. PML layer of thickness 1.0 is used. Frequency of source is 0.15 in MEP units. Resolution was set to 10 and the obstacle's width is changed during the computation.
Here, the MEP code used is shown below. We have set appropriate values for the lattice, the geometry and position of obstacle, and for perfectly matched layer thickness. Then we set up the source and set the resolution to proper value. Then we have run this code in MEP. The following observations and results are made. In case 1, here the width of obstacle is set to around lambda by 6. As we can see, whenever obstacle size is very small compared to the wavelength, the wave goes undisturbed. In case 2, here the width is set to lambda units. Whenever the obstacle size is of a comparable value to that of the wavelength, here we can observe diffraction occurring at the edges of the obstacle and thus forming the following pattern after interfering with various waves. This is what is responsible for what we observe during our daily lives, where diffraction enables various interesting applications like listening from a closed room. In case 3, here obstacle width is set to around 2 lambda. Here hardly any waves were seen behind the obstacle. This is called as geometric reflection. So everyday events like reflection from mirrors, etc. can be explained using the above pattern.